Okay, for the trigonal planar structures, what I want you to imagine first are three people with ropes. We've got a three-way tug of war going on. Now, we're going to pretend for a moment that we have three equally strong people right here. If I have one person pulling a rope in this direction, and I have another person pulling on a rope in this direction, the question is, can we set up a circumstance where we have a three-way tug of war and no one wins? Well, let's take a look. I think we can do it as long as we go ahead and have the other person pull in this sort of direction, all at 120 degrees from one another. If we're pulling at the corners of a triangle, well, then nobody should be able to win. That's the case of a trigonal planar structure. You can have three-way tug-of-wars where nobody wins. And even though there's three individual pulls on the rope, no one wins overall. There's no pull overall, and it's a non-polar molecule. So let me explain what I mean with molecules. Let's say that you have the circumstance right here where you have boron trifluoride. You have a boron on top, a boron on the bottom, and another boron on the bottom. Now, each of these fluorines is the most electronegative atom of all. Each of those fluorines are pulling on those electrons away from boron. This is a polar bond. And this bond on top is also polar, as is this bond. However, even though there are three individual polar bonds, when we look at the sum of all those pulls together, a pull in this direction with a pull in that direction, and finally a pull to the bottom, all three of those are going to cancel out. There's going to be no winner overall. No pull overall is a non-polar molecule. We have polar bonds, but the overall molecule is considered non-polar. Now, for those of you who have studied any physics at all, what you'll notice is really this is the vector sum of all these individual pulls. If I were to add all three of those individual pulls together, this one plus, I'm going to go ahead, actually I'll take this one right here, add the bottom pull down, and then finally add the last pull back, I get exactly where I was before. A zero force overall, or they'll call that a zero dipole moment. So what you need to know though is three pulls all at the corner of a triangle, nobody wins as long as all the atoms are pulling exactly the same. Fluorine, fluorine, fluorine. They're going to have a zero pull overall. Now, what if we have a circumstance, however, where we have a lone pair? So an example of that is something like OS2. Okay, if we look at this arrangement for OS2, we have an oxygen here. We have, let's put our sulfur here and our sulfur here. Oxygen has a bigger electronegativity than sulfur. It's closer to the upper right-hand corner of the periodic table. Oxygen is going to be pulling electrons away from sulfur. This oxygen is going to be pulling electrons away from sulfur. Now those ones don't cancel out. They're not directly opposed to one another. You're going to be kind of pulling overall down right here. Then, in addition to that, electrons are going to be pulled downward on this molecule. Then we have a lone pair here. There's a ton of electron density in a lone pair. So we've got electrons being pulled down, lone pairs here. Think of lone pairs as if they're not pulling at all. There's nothing to balance out these lone pairs. So this is not a symmetrical molecule at all. All the pulls will not cancel out. Because of that, this is considered a polar molecule. Pretend like the lone pairs aren't doing any pulling here. So we have a polar event. In fact, anytime you have a single lone pair, there's nothing to cancel it out. There's no balance there if there's only one lone pair. One lone pair molecules will always be polar. So we've got a circumstance of nonpolar. It's got symmetry to it. All F's on the outside, equidistant. This has no symmetry. No symmetry is going to be polar. There will be a pull. I also want you to watch out for, here I showed you an example where we had three things all pulling on the outside. Now, those were equal pulls because they were all fluorine. Well, what if they weren't all fluorine? What if I had a circumstance where I had, let's say, a boron here, and I have two fluorines, and I have a chlorine? I got two strongs over here pulling strongly, a chlorine that doesn't pull as strong. Well, then it's not symmetric again. This is not symmetrical, so there will be a pull towards one side. There will be a winner here in one direction. So if there is a pull, if there is a winner, overall, this molecule will be polar. So I hope that helps with trigonal planar structures. In the video below, I'll go ahead and talk about tetrahedral molecules.